Fine, so I'm going to be continuing on with the discussion on astrophysics. Now, last time in the last video, I did talk about this fusion process, the source of energy. I'm just going to go through it again because maybe you didn't see that one. So, looking at, I've got this this diagram over here. We've got hydrogen, the regular hydrogen isotope, which is just basically a proton. These two fuse together, we get nuclear fusion, and the deuterium isotope forms. This is with one proton and one neutron, and so that extra proton actually, the charge from that proton is given off as a positron, and you get a neutrino being given off also, and you get a gamma radiation. So that's why we get this flood of neutrinos, which are big in the news at the moment, coming from the sun. These deuterium hydrogen isotopes are fused with a further hydrogen to form helium, the helium-3 isotope. So this has got two protons, one neutron, gives a further gamma radiation, and then two of these helium-3 isotopes, they are fused and they form helium-4, which is basically the final stage. Also gives up two hydrogen, the regular hydrogen 1, just your protons, and this obviously feeds back into the whole process again, and these are used in further fusing. So this is the basic energy that from where the sun is giving. We have a mass difference in each one of these. After the fusion, there is a loss of mass, and this mass is converted into energy. And this is the energy that the sun produces that gives us life and so forth. Now, if we go back to our discussion here, I'm just going to talk about this over here. Explain that in a stable star, for example, our sun, there is an equilibrium. There's equilibrium between the radiation pressure and the gravitational pressure. So we'll just talk about that for a bit. Let me just get my going back to over here, and we'll just discuss this a little bit in more detail. All right. So if I've got the sun, let's draw a picture here. Gravity is pulling in. Because it has mass, the force of gravity is actually trying to squash or to pull in the sun, the mass here. So this is the force due to gravity. I'll call it Fg. It's squashing in there. It's trying to collapse it. Now, as it does that, it causes tremendous pressures, and also you get a real rise in temperature in the core here. So in the core here, you get this real rise in temperature, rise in pressure, and the hydrogen in here, your hydrogen in here, gets forced together, and when it gets to a high enough temperature and a high enough pressure, you get fusion inside. Now, when fusion happens, when you have this fusion, that causes an outpouring of energy, which obviously goes out. So you get an outpouring of energy which causes the particles to move quicker. You get a rise in temperature, and this causes an outward pressure. And what happens is there becomes a balance. There becomes an equilibrium between this inward pressure and this outward pressure caused by that fusion. And in the regular, like our sun at the moment, our sun is in a state of equilibrium. We could add the word dynamic equilibrium. This is a word that is used a lot in, for instance, in chemistry. Dynamic means it's movement. There's plenty of movement going, but it is balance. It's balancing. There's a balancing of forces between the two. So this is our state of the sun at the moment. It's in a stable state. We call it that it's on the main sequence. When that hydrogen runs out, it will lead to a destabilizing effect, which we will discuss later, and then this equilibrium will no longer exist. Alright, so I hope that is clear. Now the next thing that we're going to look at is this idea of the luminosity. The luminosity of a star and the apparent brightness of a star. So we'll see if we can get those two things discussed, and then I think I will start on another video. I'll bring this to an end. Fine. So the luminosity of a star. Oops. Let me change this. The luminosity is the total power of the star. In fact, our star has a total power of about 3.9 times 10 to the 26 watts. Now what does that mean? It means that every second 3.9 times 10 to the 26 joules of energy is being released. It's emitting that. We get the same thing. They use this idea with a light bulb. You may have a 60 watt light bulb. It means that the energy that is being given off is 60 watts. Every second, 60 joules per second. A watt is a unit of power. It's energy per unit time. So this is the luminosity. It's the total power of the star.